What's popping, everybody? It's Kurt here, and I'm back with another maths video. And this time, we will be focusing on the divisibility rule for the number 3. So, let's work. I almost said 9 rugby when you score a try, you get 3 points, but I think it's 5, right? I think so, yeah. Again, before I go on to a different path, when is a number divisible by 3? Let's ask the music.
For a number to be divisible by 3, the sum of the digits has to be divisible by 3. Divisible by 3. Yes. Divisible by 3.
Yes! So let's have a closer look at the lyrics to get a better understanding of the rule. Now it says, for a number to be divisible by 3, the sum of the digits has to be divisible by 3. Now, I think for us to best understand this, we need to look at an example. So let's go. Let's look at the number 273 and see if 273 is divisible by 3. Now, we have to calculate the sum of its digits. What does that mean? It means that we have to treat each digit like a separate number and add them. So 273 will become 2 plus 7 plus 3. And once we add it, we'll get the sum of its digits. So 2 plus 7 gives us 9. And 9 plus 3 gives us 12. Now it says, if the sum of the digits is divisible by 3, then the entire number is divisible by 3. So, is 12 divisible by 3? Yes, it is. Let's look at our multiples of 3. 3, 6, 9, 12. So 12 divided by 3 gives me 4 with no remainders. Okay? There we go. But hang on. If you're still going, I don't know my multiples of 3, which I hope you do and practice, there is something you can do. You can take the number 12 and apply the rule again. Add the sum of its digits. What's the digits? 12, which is 1 and 2. So let's add 1 and 2. 1 plus 2 gives me 3. And is 3 divisible by 3? Yes! 3 goes into 3 once. And there you go. That's how you apply the rule. And now we know that 273 is divisible by 3. But now, this is the thing. And this is a very, very important question to ask, especially when you're working with rules in mathematics. It's to ask, why does this rule work? Like, why? It doesn't happen magically, right? There must be reasoning and logic behind it. And that's exactly what we're going to look at right now. The logic and the reasoning behind the divisibility rule for the number 3. But just before we start, just remember, it can get a bit difficult maybe, and challenging. But that's a good space to be in maths. The more you battle and work through the questions, the more your understanding grows and the more your resilience also grows. And problems are good, problem solving is a great skill to have. So keep that in mind and let's work. We're going to use 273 as an example to see why the divisibility rule for the number 3 works. But like I said, please stay with me, pause, rewind if you must, or somebody to help you. Watch it a few times, just do what you have to do until you get it. Because once you get it and you click, I guarantee you that your understanding and your understanding of the rules will improve, and you will also realize why number flexibility is so important. Let's go. So 273. 273. We can break 273 down into 200 plus 70 plus 3. But now we're going to take it one step further and break 200 up into 2 times 100, because two 100s give you 200, And we're going to break 70 up into 7 times 10, because 7 tens gives you 70. And all this will make sense soon. Okay, there we have it. But again, we're going to take it one step further. Please stay with me. 100 we can write as 1 plus 99. 1 plus 99 does give us 100, right? And the reason we write 100 as 1 plus 99 is because 99 is divisible by 3. 3 can go into 99 33 times. You can take the calculator out and check yourself or do long division. Okay? And hope that starts to make more sense for you, because we want to check if 273 is divisible by 3. And we're breaking it up into parts to prove that certain parts is divisible by 3. And if all the parts we break it into is divisible by 3, then 273 is divisible by 3. So let's move on. 10, we're going to write, maybe some of you have guessed it, we're going to write it as 1 plus 9. Because 9 again is divisible by 3. Now it's going to get even trickier, because we're going to apply the distributive property. And we'll get to that at another time. So we'll say 2 times 1 and 7 times 1, and then we'll leave it like that. And 2 times 1 is 2 plus 2 times 99 plus 7 plus 7 times 9 plus 3. I multiplied 2 by the first number in the bracket, and then I left the other 2 together, 2 times 99. And I did the same thing with multiplication by 9. Okay? But now, have a look at this. Have a look at this section over here, and have a look at this section over here. We now know that 99 is divisible by 3. So if we have 3, 4, or 5 99s, we know that whatever we get will be divisible by 3. And therefore, the section that is highlighted green on the left, 2 times 99, that section is divisible by 3. We know that. And now the same thing with 7 times 9. We know that 9 is divisible by 3. And therefore, 7 groups of 9 will also be divisible by 3. Now we are literally left with 2 plus 7 plus 3. That is the sum of the digits of the number. But now it makes sense why we got there. And if we add these 3 numbers and the answer is divisible by 3, then our entire number is divisible by 3. So let's check. 2 plus 7 gives me 9. And 9 plus 3 gives me 12. Now is 12 divisible by 3? Yes. 12 divided by 3 gives us 4. And there we have it. If that last section of the number is divisible by 3, then we know the entire number is divisible by 3. But like I said, this might be tough for you to grasp at the start. But keep looking at it, keep asking questions, keep working on it, and this will make sense. So what we done was, we took our number and we broke it into parts. We then proved that each of these parts are divisible by 3. And that's smart, right? We used number flexibility to prove it. So we first proved that 7 times 99 is divisible by 3, which it is. We then proved that 7 times 9 is divisible by 3. And then we were left with 2 plus 7 plus 3, which is also divisible by 3. So our entire number is divisible by 3. It's just we tackle it piece for piece. Okay? So, yeah, that's the reasoning and the logic behind it. But until next time, let's recap and get out of here.